Okay, so our second video for 8.2 is going to be quicker. This we're dealing with more complex fractions, fractions where we have fractions inside. When you saw it in the last section, they were a lot easier because you just had these monomials in the numerator and in denominator. These are more complicated because you have binomials, meaning two separate pieces added together, which definitely is different from what you saw in the 8.1 with the complex fractions. So these ones, what we do is you figure out what all the LCD is, or the LCD of all of the denominators. Okay, so you're going to find the LCD of all of the denominators and then multiply it out. Okay, so find the LCD of all of the denominators and then multiply by the LCD. Okay, so when I say all the denominators, look at example 4, for instance. I mean within the two halves of the fraction, you've got these denominators. And then technically you have a denominator of 1, like over 1, so that would be your denominator there. Okay, so with A, B, B, and 1, the overall LCD would be A times B. Okay, so it's got an A, it's got a B. I don't need another copy of B because I already have one, and I really never need to include the 1 because anything is a multiple of 1. So my LCD is A times B. So when I say I'm going to multiply everything by the LCD, I mean I'm going to take the whole numerator here and multiply it by AB, and I'm going to take the whole denominator here and multiply it by AB. So what you'd look at is like, treat this as one big numerator, this is one big denominator. Really, I'm just multiplying by a fancy 1. Just like I've been doing in these previous sections. All right, so this, what I'm gonna do, I have two separate pieces. So you wanna make sure that you're distributing this AB to all of these pieces. Okay, so I'm gonna write that out. So my numerator, I have 1 over A, and then plus 1 over B. I'm spreading this out for a reason, so you might wanna do the same. And then in the denominator, I have 1 over B minus 1. So what I'm doing, I'm taking that AB and I'm distributing to each piece. So this is going to get multiplied by AB, this is going to get multiplied by AB. So every single piece, they all get multiplied by AB. All right, so it looks like we're just making things more complicated until you see what happens next. Because what happens next is a lot of canceling. So since I just chose the LCD of all the denominators, you will see that when I multiply this term by AB, these A's will cancel. And when I multiply this term by AB, the B's will cancel. And then down here, the B's will cancel. Here, there's nothing to cancel. Okay, so when you look, I no longer have any denominators. So the reason that I chose the LCD of all the denominators was so that they would all cancel out. So now this term right here, the A's canceled, I just have 1 times B, which is B, plus, and then this term, all I have left is an A, over. Here, all I have left is an A, minus, and then here I have an A times B. Okay, so this is the same fraction as I had here. This is obviously just a much less complicated version. Okay, so that would be your final answer. So let's do the same thing with example 5. Look at your denominators. We've got these 3 pieces right here. So xy is what our LCD is going to be. And with this one, the way you can think of it is like, what would make all those denominators cancel out? In order to get an x to cancel and a y to cancel, you'd need to multiply by an xy. So really, really similar to what we just did up above. So I'm going to take the whole numerator, whole denominator, multiply top and bottom by xy. And I'm going to write it out so you can see all the canceling happening. So I'll have 2 over x, leave a space, minus 1. And then 1 over y, again leave a space, minus 3 over x. So what I'm doing is I'm taking this xy and I'm distributing the xy to every single one of those pieces, and you will see my denominators canceling out. So here, this x will cancel with this x, these y's will cancel, and these x's will cancel. All right, so now I had a 2 here, and then there's just a y left, so it would be a 2y minus xy. And the 1 is, of course, always there. You don't really need to write it. And then 1 times x, so that's just an x, minus, and this would be a 3 times y. Okay, so that would be your final answer for that one. So that's how these more complicated complex fractions work.